Sorry about that. We just experienced technical difficulty. So this is 4.6, solving applications using logarithms. And this is going to be video part 2. I just had technical difficulties so that today's full lesson is broken into 2 parts. Okay, so as we were discussing about investments, there's a common formula used, which is A equals P1 plus I, all raised to the N. And we talked about A being the final amount. P is what we call the principal, and that's your initial amount. So I'll just write down principal, which is your initial or your starting amount. So that's the amount you either borrow or that you put in to invest. Okay. And ladies and gentlemen, the N is your time factor. Okay. Okay, and I is your rate of interest. Okay, and remember, 1 plus I is what we call the factor. Okay, because you're going to have to pay back the amount you borrowed plus any interest over this amount of time. Likewise, if you're borrowing, if you're investing money, you have that much of the investment in plus any interest earned on top of it. So the question says, write a model for this, write a function to model the amount A that the investment will be worth in terms of the time T in years. Okay, so all we need to do is realize that A is going to be so to answer this question, it's going to be A equals our final amount, times or equals the principal, which in this case is 3,500. Okay, times our rate, so it's 5%. Remember to change your percent to a decimal, so that's decimal 0.5, and you add 1 to it, so it's going to be 1 decimal 0.5, all raised to the T for time. All right, so that's the initial expression we're going to use that fits this model to help us with part B. Part B says, how long will it take for the investment to reach $5,171.90? So what does this represent, folks? That represents our A, our final amount. So we'll sub that in, guys. So we got $5,171.09 equals 3,500 times 1 decimal 0.5 to the T. And how long means we have to find that T equals question mark. We got to find that out. So using logarithms, folks, we're going to get the base and the base or the exponential function here, base to the power of T by itself. So we got to divide by 3,500. Whatever you do to the one side, you do the same to the other. Okay, simplifying that through, we're left with on the right side 1 decimal 0.5 to the T. And what we need to do here is take a look at dividing through. Use your calculator. Keep as many decimals as you can. So you should have 1 decimal 477 54 286. Sorry, I just ran out of room there. Okay, and now we're going to find T. So to find T, which is the time, we're going to use our logarithms. So it's going to be the log of our product, which is 1.47754286, divided by the log of our base, which is 1 decimal 0.5. Plug it in your calculator, ladies and gentlemen, and you're going to get T equals 7.99 rounded. What does that equal, guys? That's approximately, so T equals approximately 8 years. So therefore, it will take 8 years for the investment for the investment to reach or be a value of $5,151.09. Okay, let's take a look at one more example. It's dealing with sound and decibels. If you ever go to a rock concert and you're near a one of those loudspeakers, you're going to know that there's going to be a large amount of decibels, and that allows for hearing loss. So you want to maybe make sure that if you're going to concerts, folks, stay away from the big speakers. Even though you may like loud music, it does damage your hearing. All right, or it can damage your hearing. Okay, the difference in sound levels in decibels can be found using the equation. Okay, and these are just letters to represent variables. So this is beta 2 subtract beta 1 equals 10 log I2 divided by I1, where B2 subtract B1 is the difference in sound levels. So sound levels is the beta, and the I2 or I1 is the ratio of their sound intensity. So that's what the I stands for. All right, so let's compare a Ford truck with a Dodge, okay? So, ladies and gentlemen, taking a look, a Ford truck engine at peak power is 98 decibels, okay? So what do we know? That tells us that V2 equals 98 decibels, okay? And it says the sound of a Dodge engine is 72 decibels, so that's beta 1 equals 72 decibels. Okay. And then it says how many times as intense is the sound of the Ford engine to that of the Dodge engine. So let's write our initial formula in. So it's 10 log I2 divided by I1. All right, sub in the information we know, folks. So we know our sound levels, which are the decibels. So we know that it's going to be 98 subtract 72 equals 10 log of your intensity ratio. Okay, now we're going to work at simplifying the left side. So 98 subtract 72 is 26 equals 10 log of the intensity ratio. All right, now we got to focus on trying to get this log isolated, so you divide both sides by 10. So what are we left with? 2.6 equals log of I2 divided by I1. Okay. Remember here, folks, that this is base 10, okay? So what does this tell us, ladies and gentlemen? Because log is, if it doesn't, it's the common logarithm. So what does that tell us? That 10 is the base times the exponent, which is 2.6, equals the ratio. So we're just using the opposite. We're just changing the log form into the product or into exponential form. Let me fix that up. Okay, so plug that in your calculator, ladies and gentlemen. You're going to get 398.107 equals I2 divided by I1. So what does that tell us? That the Ford truck is 398 times as intense as the Dodge truck. Okay, so therefore the Ford is 398 times as intense as the Dodge. Okay. All right, ladies and gentlemen, here's your homework, page 78, 1AB, 2AB, 3, 7, 8, 10, and 12. And I'm sorry for that technical difficulty. I just apologize. I just realized I misspelled Dodge. Let's fix that right there so it looks better. Okay, guys, have a great day. And if you need any help, please come and see me. Ciao.